Hello, good day. Today's topic is AdaBoost from machine learning techniques. So, what is AdaBoost? AdaBoost is short form for adaptive boosting. It's a supervised machine learning algorithm that builds a strong classifiers by sequentially combining multiple weak learners. It was developed by Yo Free, Fion, and Robert Schaffer, and is a foundational technique in ensemble learning. So what is code mechanism like how it works? The algorithm operates iteratively with each new model attempting to correct the errors of its predecessor. And this is very important here. And initialize weights. Every training data point is initially assigned an equal weight. Train weak learners. A simple model, typically addition stump, addition tree with only one level is trained on the data. Calculate importance. The algorithm calculates the amount of, say, alpha for that learner based on its accuracy. More accurate learners have a higher influence on the final prediction. Update sample weights. Weights are adjusted for the next round. Misclassified points receive higher weights, forcing the next learner to focus on them. Correctly classified points receive lower weights. Repeat this process repeats for a set of number of iterations or until a perfect fit is achieved. Final predictions, all weak learners are combined through weighted majority to make the final classifications. And next is key characteristics of adaptive boosting, and that is AdaBoost. Adaptive, it is adaptive because subsequent weak learners or tweaked in favor of instances misclassified by previous ones. Sequential versus parallel, unlike the random forest, which builds trees independently backing. AdaBoost builds them on one after another, boosting. Focus on bias. It primarily aims to reduce bias and fitting by progressively capturing complex patterns. And now we'll compare comparisons of AdaBoost versus AdaBoost. So, what is correction method for AdaBoost increases weights of misclassified points, and for gradient boost, you have to optimize loss function using gradients. And base learner usually patient steps for AdaBoost, and loss trees or other models for gradient boost. Final results weighted majority mode and weighted sum of results for gradient boost. And advantages and disadvantages. What is pros of the boost, which is high accuracy, consistently improves the performance of any weak learning algorithm. Simplicity requires a very little parameter tuning out of the box to SVMs or neural networks. Versatile works for both binary and multiple class classifier as well as regression. Cons sensitive to noise because it obsessively tries to fix every mistake. Noisy data or outliers can significantly degrade the model. Speed slower than XGBoost because it must be trained sequentially and cannot be parallelized. Common applications are boost is widely used in industries for tasks like face detection, example the Viola Jones framework. Spam filtering and medical diagnosis for Python implementation scale learning is the industry standard. Next, we will see the AdaBoost machine in detail. So, AdaBoost is boosting techniques that combine several beam classifiers in sequence to build a strong one. Each new model focuses on correcting the mistakes of the previous one until all data is correctly classified or a set number of iterations is reached. Think of it like in a class, a teacher focuses more on weak learners to improve its academic performance, similarly boosting work. Adaptive boosting assigns equal weights to all training samples initially and iteratively adjusts these weights by focusing more on misclassified data points. For the next model, it effectively reduces bias and variance, making it useful for classification tasks, but it can be sensitive to noisy data outliers. So, original data classifiers, and when it the leftovers which are which the model unable to classify will be weight adjusted and passed on to the model again. Again, the classification, and again, the leftover is given to the next model uh, to do the classification. And this is called the ensemble classification. Training a boosting model, the above diagram explains the AdaBoost algorithm in a very simple way. Let's try to understand in the stepwise process. Initial model given the dataset consists of multiple data points, red, blue, green, and green circles. Equal weight is assigned to each data point. The first week classifier attempts to create a condition boundary. 8 data points are wrongly classified. Step 2 next is adjusting weights B2. This misclassified points from the B1 or assign higher weights shown dark points in the next step. A new classifier is trained with a redefined decision boundary, focusing more on the previously misclassified points. Some previously misclassified points are now correctly classified. 6 data points are wrongly classified. Step 3 further adjustments B3. The newly misclassified points from B2 receive higher weights to ensure better classification. The classifier adjusts again using an improved decision boundary, and 4 data points remain misclassified. Step 4 Final strong model B4 ensemble model. The final ensemble classifier combines B1, B2, and B3 to get strengths of all weak classifiers. By aggregating multiple models, the ensemble model achieves higher accuracy than any individual weak models. Now that we have learned how boosting works using AdaBoost, and now we will learn more about different types of boosting algorithm. Types of boosting algorithm. There are several types of boosting algorithms. Some of the most famous and useful models are gradient boosting. Gradient boosting constructs models in a sequential manner where each weak learner minimizes the residual error of the previous one using gradient descent. Instead of adjusting sample weights like AdaBoost, gradient boosting reduces error directly by optimizing a loss function. XGBoost, the XGBoost is an optimized version of the gradient boost that uses regularization to prevent overfitting. It is faster, efficient, and supports handling both numerical and categorical variables. Cat Boost. The Cat Boost is particularly effective for datasets with categorical features. It employs symmetric decision trees and a unique encoding method that considers target values, making it superior in handling categorical data without preprocessing. Advantages of boosting: improved accuracy by combining multiple weak learners. It enhances predictive accuracy for both classification and regression tasks. Robustness or to overfitting. Unlike traditional models, it dynamically adjusts weights to prevent overfitting. Handles imbalanced data well. It prioritizes misclassified points, making it effective for imbalanced data sets. Better interpretability. The sequential nature of the helps break down decision making, making the model more interpretable. By understanding boosting and its applications, we use its capabilities to solve complex real-world problems effectively. Implementing the AdaBoost algorithm from scratch that I will show you at the end of the video. Uh, so overall, the model performs well with accuracy of 84%, meaning it makes correct predictions most of the time. It has good balance between the predictions 0.8836, which makes accurate positive predictions, real call 0.858, which means it can reach most of the actual positive cases. The reference code 0.847 combines these two measures, and ROC AUC 0.839 shows the model does a good job of telling the difference between the two classes. Overall, these metrics indicate the good performance. That's it for today. And next coming up with the implementation of the code, and this particular is talking about the model performance of that code which we are going to implement, which I will show. So continue the AdaBoost or adaptive boosting and implementation of the AdaBoost algorithms from scratch. So now we starting from AdaBoost means adaptive boosting, which is a simple learning techniques that combines multiple weak classifiers to create a strong classifiers. So how are we going to do it? So let us see. So we'll begin with by importing libraries like NumPy, scikit, learn, which requires to do classification tasks. So in this, in the sklearn tree, we import the decision tree classifier, and sklearn dataset we import the load Irish dataset, and sklearn datasets import make classifications. Sklearn.model underscore selection, we are importing train underscore test underscore split model. And sklearn.metrics, we import the accuracy score, confusion metrics, precision score, recall score, F1 score, or ACAUC score. So now defining the AdaBoost classes, in this step we define the custom class called the AdaBoost. So AdaBoost class is where we define the entire AdaBoost algorithm, which consists of the initializing the model parameters like uh, number of estimators here and weights and the model, and fitting the model to the training data, making predictions like using the train model. So next is the constructor, the initial initialization, the number of weak models in estimator to list to store the alphas, self.alphas, and list to store the weak classifier self.model. So the next one is we see the training the AdaBoost models in the fit of method we do. So sample weight initialization we are doing with this code, which is W is equal to np.1f and samples by n underscore samples. Initializes all sample weights equally. Training with the weak classifiers. So here we are training with the weak classifiers, and addition tree classifier is used here, and the depth of one is trained using the current sample weights. Error calculations, we are also calculating the errors over here and computes the weighted error of the classifier. And here the alpha calculations, alpha calculates the classifier's weight alpha. Next, updating the weights. So here we are updating the weights here. Misclassified sample weights are increased using the W equal to NP. So this line and more normalized with this particular command. So define the predictive methods. In the predictive methods, we combine the prediction of all weak classifiers using their respective alpha values to make the final predictions. So here we are doing the final predictions, and strong predictions we are doing with LP dot zeros of x of shape of zero initializes an array of zeros to store the weight weighted sum of predictions from all weak classifiers. For models alpha in zip, or here what happens is loops through the each trained models and its corresponding alpha values. So here the strong predictions, here what happens is like adds a weighted prediction to of each weak model to strong predictions. So here it is like what is happening is take the sign of the sum of the classify samples as one positive class or a negative class. So example usage we are showing here. We are generating the synthetic data set with 1000 samples and 20 features. And then we what we are doing is we are splitting. This is the split model. For test size, zero point 0.3 and random state 40. And AdaBoost we are using here, we initializing the AdaBoost classifier with 50 estimators. And next, after training, we predict the tests and set and evaluate the model here. We are evaluating the models. So here we can see accuracy of this particular model 84.04%, 0%, precision 0.8364%, recall is 0.058 percent, and F1 score is P 0.8471%, ROC AUC score is 0.8393 or 94%. That's it.